In this video, I'll continue with relations and functions. That is the chapter 1 of NCERT Mathematics. Here I will solve the questions from exercise 1. So the first question in exercise 1.2, show that the function f from r star to r star defined by f of x is equal to 1 by x is 1 to 1 and on to, where r star is the set of all non-zero real numbers. Is the result true if the domain r star is replaced by n with codomain being same as r star? So here we are given the function f is from the set of all non-zero real numbers to the set of all non-zero real numbers defined by f of x is equal to 1 by x. We have to show that f of x is 1 to 1 and on to, and then we'll come to the next part of the question. So here, for the function f from r star to r star, first we will prove f is 1 to 1. Let x1, x2 belong to r star, and let f of x1 equal to f of 2. So if f of x1 equal to f of x2, then we have 1 by x1 is equal to 1 by x2. Since it is given f of x is equal to 1 by x, so f of x1 equal to f of x2 means by x1 equal to 1 by x2. So this implies x1 is equal to x2. Therefore, f is 1 to 1. Now, we'll prove f is on to, let y belong to codomain r star. Then y is equal to 1 by x implies x is equal to 1 by y. Therefore, f of x is equal to 1 by y is equal to y. Therefore, f is 1, 2. Now the next part of the question, is the result true if the domain r star is replaced by n with codomain being the same as r star? So if we take for function f from the set n of natural numbers to the set of non-zero real numbers, we can see that f is 1 to 1. F is 1 to 1, but it is not onto, because we take the non-zero real number minus 1, it belongs to r star, but it does not have a pre-image. So therefore, f is not onto. So here, in this case, when the function f is from the set of all non-zero real numbers to the set of all non-zero real numbers given by f of x is equal to 1 by x is 1 to 1 on and on to. If the function f is from the set n of natural numbers to the set of non-zero real numbers, then f is 1 to 1, but it is not. Next question, check the injectivity and surjectivity of the following functions. First one, the function f from the set n of natural numbers to the set n of natural numbers given by f of x is equal to x square. So here first we will see whether it is 1 to 1 or not. Let x1 to belong to n, and let f of x1 equal to f of x2. So if f of x1 equal to f of x2, then x1 square is equal to x2 square. Since it is given f of x is equal to x square. So from this we get x1 is equal to x. Therefore, f is 1 to 1. Now, or it is injective. that is f is injective. F is 1 to 1 means f is an injective function. Now we have to prove whether, we have to check whether f is surjective or not, that is f is onto or not. We take the natural number 2 belongs to n, but it does not have a pre-image. So therefore f is not. Next question, check the injectivity and surjectivity of the following functions. The function f from the set of integers to the set of integers given by f of x is equal to x square. So here we take f of 1 is 1 and f of minus 1 is also equal to 1. Therefore f is not 1 to 1 because two numbers have got the same image. So f is not 1 to 1 or injective. Now we have to see whether f is surjective or not, that is f is onto or not. We take the integer minus 1 belongs to z but does not have a pre-image. Therefore f is not onto. Next question, the function f from the set R of real numbers to the set R of real numbers given by f of x is equal to x. Here again if we see f of 1 is equal to f of minus 1 is equal to 1. So f is not. And we take the real number minus 1, it belongs to R but it does not have a pre-image. So f is not onto also. Therefore f is not. Next question, the function f from the set n of natural numbers to the set n of natural numbers given by f of x is equal to x cube. So here you can see that the function f is 1 to 1 because let us take let x1 x2 belongs to n and let f of x1 equal to f of x1 equal to f of x2, then x1 cube is equal to x2 cube. From this we get x1 is equal to x. Therefore this 1 to 1 are injective. On the other hand, if we take the natural number 2, it belongs to n but it does not have a pre-image. So f is not. Therefore f is not. Next one, the function f from the set of integers to the set of integers given by f of x is equal to x. So here we can see that f is 1 to 1. Let us take let x1 x2 belong to set and let f of x1 equal to f of x2. So if f of x1 equal to f of x2, then we have x1 cube is equal to x2 cube. So this implies x1 is equal to x. Therefore f is 1 to 1. Now to see whether it is on to, if we take the integer 2, it belongs to the codomain but it does not have a image. So therefore F is not. Next question. Prove that the greatest integer function f from the set R of real numbers to the set R of real numbers given by f of x is equal to, this is the greatest integer function, is neither 1 to 1 nor on to, where this denotes the greatest integer less than or equal to x. So we have to prove that this is neither 1 to 1 or. So if we take f of 1.2, the greatest integer which is less than or equal to 1.2 is equal to 1, and if we take f of 1.3, then the greatest integer less than or equal to 1.3 is also equal to 1. So we have two elements in the domain having the same image 1. So f is not 1. Therefore f is not 1 to 1. And then if we see the number 1.5, it is a real number. It belongs to R but does not have a pre-image. Therefore f is not 1, 2. Question. Show that the modulus function f from the set R of real numbers to the set R of real numbers given by f of x equal to mod x is neither 1 to 1 nor on to, where mod x is x if x is positive or 0 and mod x is minus x if x is negative. You are familiar with this modulus function. So here if we see, it is not 1 to 1 because if we take f of 1 is also equal to 1 and f of minus 1 is also equal to 1. So therefore f is not 1 to 1. Now if we take the real number minus 1, it belongs to R, the codomain, but it does not have a image. Therefore f is not. Question. Show that the signum function f from set R of real numbers to the set R of real numbers given by f of x equal to 1 if x greater than 0, 0 if x equal to 0, minus 1 if x less than 0 is neither 1 to 1 nor 1 to. So here f of x equal to 1 if x greater than 0. So when we take f of 1 is equal to 1 and f of 2 is also equal to 1. So therefore f is not 1 to 1. Then we take the number 2, it is a real number, it belongs to R but it does not have a pre-image. Therefore f is not. Question. Let A is equal to 1, the set 1, 2, 3, B is equal to the set 4, 5, 6, 7 and let f is equal to the ordered pairs 1, 4, 2, 5, 3, 6 be a function from A to B. So that f is 1 to 1. Here if we see the function, here we have 1 is mapped to 4, 2 is mapped to 5 and 3 is mapped to 6. So each of these, that is different elements in the domain, have different images in the codomain. So we can see that f is 1 to 1. F is 1 to 1 as different elements of domain have different images in codomain. The next question, in each of the following cases, state whether the function is one-to-one, onto, or bijective. Justify your answer. First one, the function f from the set R of real numbers to the set R of real numbers defined by f of x is equal to 3 minus 4x. So here we have to check whether the function is one-to-one or onto or both one-to-one and onto. So here let us take let x1 x2 belongs to R and let f of x1 equal to f of x2. So f of x1 equal to f of x2 means 3 minus 4x1 is equal to 3 minus 4. So from this we get 1 is equal to 2. Therefore f is 1-to-1. Now let us see whether f is onto or not. Let us take let y belong to the codomain. So y is equal to 3 minus 4x. From this we get x is equal to 3 minus y by 4. So f of x is equal to 3 minus 4 into 3 minus y by 4. So we get this is equal to y. So we got f of x is equal to y. Therefore f is next question. The function f from the set R of real numbers to the set R of real numbers defined by f of x is equal to 1 plus x square. So here you can see that f is not 1-to-1 because we take f of 1, it is equal to 1 plus 1, 2, and f of minus 1 is also equal to 1 plus minus 1 the whole square, which is 1 plus 1, 2. So two elements in the domain have same image in the codomain. So f is not f of 1 equal to f of minus 1 equal to 2. Therefore, f is not 1-to-1. Then to see whether f is onto or not, if we take 0, it belongs to R, but it does not have a the image. Therefore, f is not onto. Next question, let A and B be sets show that the function f from A cross B to B cross A such that f of A comma B equal to the ordered pair B comma A is bijective function. So it is given the f is a function from the cross product of the sets A and B to the cross product of B and A such that f of the ordered pair A comma B is equal to the ordered pair B comma A. We have to show that f is 1-to-1 and onto. So first let us take let A comma B, the ordered pair A comma B, C comma D belong to A cross B. And let us take let f of A comma B equal to f of C comma D. If you are able to show that A comma B equal to the ordered pair A comma B equal to the ordered pair C comma D, then we can say f is 1-to-1. So if f of A comma B equal to f of C comma D, it means It is given f of a comma b equal to the ordered pair b comma a. So which means the ordered pair b comma a is equal to b comma. If the ordered pair b comma a is equal to the ordered pair b comma c, then b equal to d and a equal to c. Therefore, b equal to d and a equal to c, which means the ordered pair a comma b is equal to the ordered pair c comma. Means therefore f is 1 to 1. Now we have to prove f is 1 to. So let us take that b comma a belong to the codomain b cross. So if b comma a belongs to b cross a, then a comma b belongs to a cross. This is by the definition of cross product. The definition of cross product. Therefore, f of b comma a equal to ordered by a comma. So which means f is. So we have proved that f is 1 to 1 and f is on to. So f is a bijective function. Therefore f is bijective. Next question. Let f from the set n of natural numbers to the set n of natural numbers be defined by f of n is equal to n plus 1 by 2 if n is odd, n by 2 if n is even, for all n belongs to n. State whether the function f is bijective. Justify your answer. So here, if we take the number 1, 1 is odd. So f of 1 will be 1 plus 1 by 2, it is 1. If we take the number 2, 2 means 2 is even. So f of 2 will be 2 by 2, that is equal to 1. So we get f of 1 equal to f of 2 equal to 1. Or two elements in the domain have the same image in the codomain. So f is not 1 to 1. So f of 1 equal to 1 plus 1 by 2, that is 1, and f of 2 is equal to 2 by 2, it is 1. Therefore, f is not 1 to 1. So since f is not 1 to 1, f is not bijective. Hence, f is not bijective. Next question. Let a equal to the set R of real numbers minus the singleton set 3 and b equal to the set R of real numbers minus the singleton set 1. Consider the function f from a to b defined by f of x is equal to x minus 2 by x minus 3. If is f 1 to 1 and on to, justify your. So we have to find whether f is 1 to 1 and on. Now let us take, let x1 comma x2 belongs to a, and let f of x1 equal to f of. So if f of x1 equal to f of x2 means 2 minus 2, x1 minus 2 by x1 minus 3 equal to x2 minus 2 by x2 minus. Now let us cross multiply. So we get 1 x2 minus 3 x1 minus 2 x2 plus 6 is equal to x1 x2 minus 2 x1 minus 3x2 plus 6. So this 2 will cancel out and we get x1 is equal to, therefore f is 1 to 1. Now we will prove f is on to. So let us take, let y belongs to b. So y is equal to minus 2 by minus. So when we simplify, y minus 3y equal to minus 2, or y minus x is equal to 3y minus 2, or x is equal to 3y minus 2 by y minus 1. So f of x will be, f of x is equal to minus 2 by x minus 3. In place of x we have to substitute 3y minus 2 by y minus 1. Okay? 3y minus 2 by y minus 1. So this is equal to 3y minus 2 minus 2y plus 2 divided by 3y minus 2 minus 3y plus 3. So we get y. 3y minus 3y will go, minus 2 plus 2 will go. So we get 3y minus 2y y divided by 3 minus 2, 1. So this is equal to y. Therefore f is on. Therefore f is on. So we got f is 1 to 1 and f is on. The next question, let f from the set R of real numbers to the set R of real numbers be defined as f of x is equal to raised to 4. Choose the correct answer. So we have to see whether f is 1 to 1 onto, many to 1 onto, 1 to 1 but not onto, neither 1 to 1 nor on. So here if we take f of 1 is 1 raised to 4 1 and f of minus 1 is also 1 raised to 4, it is 1. So we have two elements in the domain having the same image. Therefore f is not. And if we take minus 1, it belongs to R but it does not have a image. So f is not. So the correct option is. Next question. Let f from R to R be defined as f of x is equal to 3x. Choose the correct answer. So here if we see f is 1 to 1 because when we take x1, x2 belongs to R, f of x1 equal to f of x2, then we get 3x1 equal to 3x2 or x1 is equal to x. So therefore f is 1 to 1. Now to see whether f is on to, let us take let y belong to the codomain R. Then we have y is equal to 3x or x is equal to y by. So f of x is equal to 3 into y by 3 is equal to 1. Therefore f is 1 2. So among the four options, 1 to 1 onto, many to 1 onto, 1 to 1 but not onto, neither 1 to 1, A is the correct option. Not f is 1 to 1 and f is correct option is. I hope this video was useful for you. Thank you for watching.